Okay, so like I said, you know about an equilibrium. It's better to talk about thermal equilibrium to acknowledge that it's temperature dependent, but it's even better to know what that temperature dependency is, and that's the Boltzmann distribution. So that's the first lecture in this course. Is the Boltzmann distribution ties what we did in the fall, or back when you took quantum, whether it be the spring or a year ago in the fall. It ties those quantum states to the thermodynamic properties that you're used to hearing about. So what are the thermodynamic properties? If I were to ask you to describe the like the vocabulary and the terms that you use in thermodynamics, what would be some things that you would throw out?
Energy cannot be created or destroyed.
Yeah, that's good. The laws of thermodynamics, you can't create or destroy energy. It's converted, transferred, but it's not created or destroyed. Very good. So energy is a big one. What words do we use for energy? There's lots of different types. Entropy is interesting. Yeah, we're going to talk about that. Enthalpy, yes, the heat of a reaction is enthalpy. And so this Boltzmann distribution, once we learn about that, it is what converts the statistical like population of energy levels into entropy, enthalpy, Gibbs energy. A new one that you haven't heard of probably is Helmholtz energy and the equilibrium constant. And so that's the first part of this course, is to transfer our thinking from quantum states and energy level diagram to enthalpy, entropy, whether something's spontaneous or not. Which side of the reaction arrow will the products or reactants be most abundant, and so on. And so that's what we're going to dive in. That's what it's a whole course called Statistical Thermodynamics that I took in graduate school, and there's one little chapter in Atkins on it. So it's rarely taught in undergrad, but I teach quantum first and thermo, and this chapter is the bridge. And so we're doing, I think it's like chapter 32 or something in the book. It's way in the back of the book, but we're just putting it in here for just a few weeks to build that bridge from quantum states into bulk properties. Okay, but first let's do the introduction to the course. I mean, that was kind of an introduction to the course. Let's do the syllabus, and we'll talk about the path that we're going to go through in this course. So we're going to start out with, you were here, the quantum realm is that way, 4448. And we're going to go through probability, Boltzmann distribution, partition functions, and so on. These little switchbacks are the different lectures that we'll have. And we'll have our first exam. And at the top of the hill, we'll know all kinds of things. We'll be able to look out at the vista that we've built and see entropy, enthalpy, and Gibbs energy, and all of those things, and how they relate to the energy level diagram. So where the energy levels are in a system, like a molecule or an atom, whatever. And then we're going to start something different. We're going to go over to bulk thermodynamics and learn about thermochemistry, which you already know, that enthalpy of reactants minus the enthalpy of products, you get delta H and delta S and delta G. You've already done a little bit of that. We'll review that. And then we'll apply it to engines, heat engines, jet engines, automobile engines, and so on. You'll be able to take the numbers that you hear on an automobile, like the displacement, like a 5.2 liter engine, and you'll know what that means. And you'll be able to convert that into changes in energy, enthalpy, and so on. So that's the engines part, thermodynamic laws and cycle problems. So heat engines and cycle problems. Then we'll have an exam on that. Then we get into phase diagrams and mixtures, azeotropes, and separations. And so all of you have been through organic, you've done distillation, you've done melting points, and so on. This will look at the diagrams of those phases, and you'll understand a lot more in depth about why and how distillation works, why and how a melting point, if it's off from its maximum value, that the substance is impure. And so we'll see that evidence in our phase diagrams, and you'll learn a lot about that. There will be an exam. And then thermoconductivity, diffusion, viscosity, and flow, those are non-equilibrium systems. Because there's flow, there's a gradient, and nature hates a vacuum or a depression. It wants to fill voids and so on. You have a pothole in the road and it rains, water's going to collect in that pothole. Okay, same thing happens in non-equilibrium systems energetically. If you've got something cold in a hot room, the heat is going to flow into that cold thing. Okay, and that's not at equilibrium. If they're not at the same temperature, they're not at thermal equilibrium. So these are non-equilibrium systems. All of our batteries work. If we have an equilibrated battery, it's dead. So the very fact that it's not equilibrated is what makes a battery useful. And so that's that fourth section. And then the fifth section, we've gone from the quantum realm, tiny little energy levels in a subatomic particle like an electron. And now we're going to talk about all the way up to the energy of the global sources of energy, like how much energy the whole globe uses, how much energy the sun provides to the earth, and how we convert that to all the different energy sources that we use and the sinks and the changes between them and the efficiencies of all of those. So it's a really broad course, but it's a really lot of fun, especially when we end on energy and you can sort of use your new skills in understanding the energy balance of the world. You can really see a lot of crazy stuff in the news, and you're like, I know for a fact that's not right. so that's always a good place to end. Let's do the syllabus. Let me switch over to Adobe, to Acrobat, and we'll get the syllabus set up. Okay. Let's see, did that work? What's that? Capture display. Okay, yeah, we're good. Okay, very good. No, not good. Say that again. You will in a second. Yeah. Let's see. I'm gonna scoot this over here. Is it coming over? Yeah. All right, great. And yeah, there it is. Okay, very good. Let me see if I can put up here a little bit. Okay, good. So we'll just go through the main points. I've highlighted some things for lecture. They've done the simple syllabus. Are you familiar with the simple syllabus now? It's all part of Blackboard. Maybe not all your professors use it, but I found it to be an okay tool. And so we'll run through some of the main points, but a lot of the stuff is very similar to my classes before. So if you have me in PChem 1, it's very similar things. My office hours are right after class, 9 to 10. I realize that you may have class at that time, and so just email me and we'll schedule another time. I'd like for you to learn how to use the Outlook scheduler so that you can send me an appointment request. And if you do that, my schedule's in Outlook, and so you can do the scheduling assistant, and you can see where I have open times. And so the 90% of my schedule's on Outlook. There'll be things that pop up, and so I'll respond back if that's not a good time with a suggested time, and then we can negotiate when we can meet. Okay, so don't feel like if you can't meet at 9 to 10 that you can't ever get a hold of me. Okay, I do have a big active research grant, and so I do disappear a lot of times in the afternoons to work on that. And so that's where I'm at. I'm not at home, playing games or something. I'm working on my research. Yeah. So do that. Email is the best way to keep up with me because it stays in my inbox until I address it. And so that's sort of my to-do list. Okay. Now, some of the big ideas in the course, we're going to be explaining the foundation of quantum mechanics and thermodynamics and making that connection. Basically, what I just did with the little pretty picture of the mountaintops. This is what's in your syllabus. I would like for you to get the book because you're building your library. You're not buying the book just for this course. You're buying the book for your library. It is a really thick book. We'll never go through the whole thing in one semester or even two. There's lots of things in there that you may not cover in your undergrad, but you may get into industry or into your next educational thing and need to refer to it. It's a good reference book. So a Gen Chem book and a PChem book are probably the two best books in your library. Organic, you can use that as a doorstop. All right, so yeah, so my syllabus used to be 2 pages, and we went to simple syllabus, and it's 11. So anyway, there's a lot of a lot of stuff in here. Here's all the assignments, but this is populated from Blackboard. It's not going to be updated when Blackboard changes, and so always go to Blackboard for the list. But they made us do this so that the syllabus had all of those things in it. But Blackboard is going to be the schedule, and if we move assignments around or whatever, it's Blackboard that's binding in terms of the scheduling of the assignments. The assessment breakdown is very traditional, 90 and above a, 80 to 89 B, etc. I reserve the right to move that down a little bit. Like if there's, let's say for the A group, if the course is particularly hard this semester and the high grade is like a 92 and the lower of that A group is an 89, and then there's a gap of like 3 points, and then the next student is like 85, and so on. That 89 is behaving more like the A group than the B group. And so that's how I decide when to move things. I'm not aiming for certain percentages of A's, B's, and C's, but I'm looking at the groupings. And so if there's a grouping where that person is more behaving like, in their grades, behaving like the A group, then I will drop it down to 88 and then capture that 89 in the A group. So that's how I do it. Same with the DF cutoff or the C D cutoff. If the person that is at a whatever the D cutoff is 65, let's do 69 and 70. So DC, that's the really important one. If the person's got a 68, but they've been here every day and they've turned in every homework and they've turned in every lab, that's the thing that really catches people. They're giving it their all, right? And so if there's that person would get scooped up into the C group because they made an effort and they stayed on track. Okay, the lab is the biggest killer in terms of people staying on track. But at least this lab is not a writing component. So you're going to have like a template, a word template. Yeah, everybody's like, okay, you still have to write. Okay, you still have to write complete sentences. You got to tell me and the TA that you know what you're doing, right? That's the goal of the lab, okay? But there's discussion questions, no introduction or anything like that. So you'll do the lab, you'll go to the discussion questions, and there's like a word template. Insert your figures here, insert your answer here, leave the questions in there so that we know, what you're answering. So that's really great. Question?
Is it candid?
Yeah. Okay. Good. All right. So stay on track. Yes. Okay. So this is the weighting factors for labs and exams and all of that stuff. Okay. And then the final exam. It's really weird. This is the first year they published the final exam schedule really late, like 2 days ago. And normally it's done, a month in advance. But yeah, I checked again. This is the final exam, May 7th on Thursday. So that's, I don't know, it gives you a longer time to study, but that's the last day of exams. And so we kind of, got to wait until Thursday to take your final. Okay, sign the roster every day. I don't want a bunch of doctor's notes because it's such a small percentage of your grade. I don't want a lot of paperwork and everything like that. Just show up, sign the roster. If you get 3 free misses, okay, so it shouldn't be a problem. Even if you miss that 4th one, it's less than 1% on your weighted average. It's like 1,000th of your grade. Okay, so I don't want to fiddle around with a bunch of notes and things. Okay, did the grading scale, late policy. Did y'all? Okay, late reports. I hated always going through school. If you're a minute late, you lose like 80 points or something ridiculous, right? And I always hated those discontinuities, and nature hates those too. That's why nature has the natural log and the exponential function. And so at 11:59, if you're, let's say your lab is 1 hour late, okay? It's 1 hour divided by 24 hours times the natural log of 2. Change it to negative exponent. And so they would grade your lab report, you'd have your initial points, and then that late factor would reduce that a little bit. And 1 out of 24 is a small factor, okay? You'd lose half your points in 24 hours. So if you need to work until 1 just to finish up that last question, go ahead and do that, okay? But don't wait till 2 or 3 days. After 3 or 4 days, you really don't have any points left. At that point, just turn in whatever you have on the discussion questions as is and get it turned in, because you can't have any absent labs, any missing labs. And the reason I have that strong policy of if you skip a lab or skip an Excel file, you could fail the whole course. Okay, And the reason I do that is because I had students that at the end of the semester would just not do the last 2 labs. And you can't do that in the workplace. You know, if your boss says, I need a report from you, and you're like, well, you know, my performance review was last week, and I know that we start over at next week, and so this week is really on my performance review, so I'm just not even going to do it. You're fired, okay? And we don't want to build that habit here in college that will get you fired in the workplace. So that's a terrible attitude to have, to say, well, I'm just not going to do those because it's not worth it enough for me. Okay, so bad habits we want to get rid of. It says this is a wrong word, a typo. It says AI is not permitted for assistance with grammar, spelling, and it is permitted for grammar and spelling and so on. So you can paste your text in there if you're a sketchy writer, okay, and say, please correct this for grammar and spelling, and it'll do that. Maybe rephrase a sentence or two, and you just cite your work to say, I used AI to clean up my sentence structure, okay? Now, I doubt, at least at this point, I doubt AI is going to be understanding a lot of my assignments, okay, especially the statistical thermodynamics and the Maxwell construction and all of these other things. Okay, so I'm not really worried about you using it for the content, but if you do use it for the content, and I think you just copied and pasted AI, I'm going to pull up a Zoom with you, and I'm going to ask you questions on every word that's in that answer. And if you can explain it, great. If you can't explain it, then you get a 0. So beware using AI. If it pushes out a lot of words that you're like, well, that sounds good, but I have no idea what it's talking about, not good. Because if I ask you about that, you could fail the whole assignment. Okay, so it's fine to use AI. We want to learn how to use it ethically, though. Okay, so there's also a schedule on Blackboard, but here's the whole schedule. Weekly homework assignments due Saturday night. It's not because I want you working on the weekends, but a lot of people need that Saturday because they work during the week and so on. So it's available for you, but if you have questions, start on it early so that you can ask them during the week. Because I travel a lot. I get out of town on the weekends. I'm probably not going to be able to answer your questions on Saturday. So you want to get your questions answered by Friday. So start on the homework as soon as you can. Sometimes the homework, you look at it and you go, we haven't had that lecture yet. You want to start on it on a Tuesday, and we haven't gotten there yet in the homework. Okay, all my lectures are online. Last year's lectures are online. 4449, the playlist for 2025. And so you can look at those next 2 lectures, or just look at the notes on Blackboard for the next 2 lectures, and maybe you'll be able to figure it out. Okay, so don't forget, you can get ahead on the homework and try to figure it out. And that'll prime the pump, and then you can ask questions in class. Okay, very good. Good strategy. Let's see. I think that's about it. What page are we on? The labs will start in here in the 3rd week. Okay, so you'll come here for lab. We'll do some of the labs up in my research lab. We'll do some of the labs in 313. So read ahead, look to see if it's an Excel exercise in here, or if we're going to the lab. When we get to bomb calorimetry, we're going to go to the lab for 3 weeks, and so that's the day you'll need glasses with side shields, your legs covered, no open-toed shoes. So regular lab clothing. So I don't know if you have a place here at the department, you can kind of keep your lab garb or not, but yeah, make sure you bring that to school on those days so that you don't have to go back home. Some people drive a ways. Exams will be multiple choice with a written question or 2. So bring a Scantron to the exam. Bring pencil. You can do note cards in this course with equations and stuff, and a calculator that cannot connect to the internet. So can't use your phone or a tablet, but you can use your regular PI-83 or whatever you got. Don't cheat. Okay, academic dishonesty. 10 consecutive words from a source without quote or attribution is considered plagiarism. So we still, even with AI, want to use that to say, look, I started with AI to brainstorm or to check my grammar, but I went through and edited it. But you cite which one you used. Is it Grok or Chat GPT or whatever? Okay. All right. I think that's it. So what I want to do now is I want to rearrange the notes. Let me stop this video recording and we'll start again. So this is just the lecture video on the syllabus. Okay. So